All right, let's get started here. So, for this test, we went over a few things. I'm going to write them down very quickly, actually, just to kind of recap all the things we learned. So we did perimeter, area, we did composite shapes, so this applies to both of those. We did perimeter and area, both composite shapes. We also did volume, which we did recently. We did optimization or optimization of area and perimeter. And the last thing we did was Pythagorean theorem, or the last thing I think I left off this list. So there should be basically 5 things that we did do. Alright, so we're going to start off just recapping what the Pythagorean theorem is. So what is the Pythagorean theorem? It is a formula used to determine the length of one side of a triangle, and just not just a right triangle, or not just any triangle, but a right-sided triangle, or right angle triangle. So that's critical here. A right angle triangle if two sides are known. Alright, so we have to know two other sides to be able to find the one side, and it only works on a right angle triangle. So what it's like, whatever, what it finds, what's its purpose, we've kind of just identified that, which is the finding the unknown side, right? Find an unknown side. Find the length of an unknown side. Okay, so what specific triangles does it work with? Right angle triangles. And that's it. It's the only kind of triangles it works for. If it's not a right angle triangle, we're not going to do it. Alright, so we're going to use Pythagorean theorem to solve for the unknown side in each triangle. Round your answer to 1 decimal point if needed. Okay. So the critical thing is labeling our triangle correctly, because our formula, if we recall, is a squared plus b squared is equal to c squared. And c must be the hypotenuse. It has to be the hypotenuse every time. Alright, so if we take our formula and we try and solve for this one here, so we have, in this case here, C is going to be our longest side, which is 18, and then A and B, it doesn't really matter. So in this case we're solving for B. So if we're solving for B, we rearrange our formula, right? Let's take our original formula for a second. A squared plus B squared is equal to c squared. Now, if I wanted just to get b squared by itself, I have to get rid of a squared. So I'm going to subtract by a squared. And whatever I do to one side, I have to do the other side. So once I've subtracted by a squared, these two cancel each other out, and we're just left with b squared is equal to c squared minus a squared. Alright, so if we substitute in our values, So we have b squared is equal to 18 squared subtracted by 12 squared. B squared is equal to 18 squared. What is 18 squared? It's a good question. I don't know offhand, so I'm going to do it myself on my calculator. 324. Okay, 324 subtracted by 144. And we get b squared is equal to 180. And our last step that we have to always remember is taking the square root. So we're going to take the square root of 180. And we get 13 point something probably. 13.4. Alright, there's our answer. And we want to make sure we use our units. Centimeters. Okay, so we found it. In this case here, question B, I always find it easier because, and most people on math tests tend to do better on it when I leave it so that you just have to solve for the hypotenuse. So in this case here, we need to find hypotenuse. So that's the letter C. So we're going to use the letter C. C squared is equal to, and we can just substitute our other two sides in. And we got c squared is equal to 49 plus 16. C squared is equal to 5565. And so c is going to equal to the square root of 65. So c equals, what, 8.1? Maybe? I guess? Yes, 8.1. All right, so that was an easier one because we don't have to rearrange the formula, and we don't. Now you don't always have to rearrange the formula and show me that you'd have to do that. I'm just doing that for your own benefit because some of you might already recall that if you're looking for a shorter side, you just take the longer side squared subtracted by the shorter side, one of the shorter sides. All right, what is a composite figure? Oh, I'm so glad you asked. All right, so let's do a nice composite figure, and this will be. Oh, let's change our pen here. Nice drawing. Here's my composite figure. Except it's going to be Andrew's house. It has a very steep roof. Right? Nice house, Andrew. And you know what? I think we need to put a chimney on this roof, so let's go like this. So we can add to our compositeness. Look at that. So much more composite now. And we would provide measurements if we wanted to. Like we could go like, this is 14, this is 12, this is 3, and yeah, you could figure it all out. Alright, so a composite figure is just a bunch of figures, shapes, or basic shapes kind of glued together. Okay, so like Andrew's house. Alright, so let's explain the steps to calculate the area of a composite figure. Include a diagram. Well, I'm going to use an easier diagram this time because Andrew's house is going to take too long. So let's just go like this. Let's go like that, and it's going to be kind of an ugly diagram, but that's okay. Alright, let's look at this here. So let's make this 10, 10, so that's 10, and what's a good triangle that I can do here? 8 plus 6, yeah, I'll do that. Maybe actually, but I have to do 10 plus, because this is 10 now. And then this is... Oh, let's take that off. Let's make this 8. Okay. So we need to find the area of the composite figure. Well, we break it into parts. That's our first step. So break it down into recognizable simple shapes. Break into simple shapes. Meaning like triangles and squares and that kind of thing. All right, so step 2. Find area of each shape. And then the last step is adding all the areas together. To find the total area. All right, so it's just a little 3-step process. Break it down, find the area of each one, and then keep going. Okay, circumference of the circle. This one, we're going back to our formula for circumference of a circle. C equals 2 pi r. So circumference is equal to 2 pi r, so we go 2 times pi. You can use 3.14. You can press your pi button if you want. I'll use 3.14 this time, and I'll use the pi button on the next question. So 2 times 3.14 times 7. C equals 43.96, and I'm going to just round to 1 decimal place, so I'm going to change it to 44.0 centimeters. All right, what about the perimeter of this figure? Well, this one's going to be a little bit different, right? So our perimeter, I'm going to make our equation first off. So we have 8 meters here and 8 meters there. So it's going to be 8 plus 8 plus, and then this section right here, well, that's half of a circle, right? So perimeter of a circle is 2 pi r, so we want half of 2 pi r. And by the way, these 2's are going to cancel each other out, so it's just going to end up being pi r, but if you want, we can put it right here. All right, so we're going to keep the 8's out front, because we know what those are. Or you can combine them to just make 16. In any case here, yeah, these will cancel. And we have pi times, and we're given a diameter of 6, so our radius is going to be 3. So 16 plus 3 pi, which is what, 9.52. So we got 25.52, which I'm going to round off again. It's 25.5 meters. Okay, so pretty simple so far. What if it's not that kind of shape? What about a trapezoid? Well, let's look at it here. So we can see that certain sides are the same. This side here is the same as that side, right? So for in this case we have 2 times 2.3, and then we just have to add the 2 oddball sides. We have one short side and we have one long side. So we end up with 4.6 plus 1.4 plus 3.4. So 5, 6, 9.4, and my units are meters. There's my perimeter for that shape. Now the area is a little bit different. So area of a trapezoid. Now, if you don't even have this in front of you, you can always Google it. But basically, it's the formula for area of a trapezoid is kind of like this. It goes A plus B divided by 2 times height. All right, so in this case here, we'd go 1.4 plus 3.4 divided by 2 times 2.1. So we get 3.8, 4.8 divided by 2 times 2.1. And so that's 2.4 times 2.1. And since I don't like doing decimals in my head, I'm going to do this on my calculator. 5.04. Or let's just round to one decimal place, 5.0. And it's meters squared. Okay, so far so good. One last area. This one is the shaded region. So we're going to subtract the unshaded region, right? So we have to find the area 1 and area 2. So area total is equal to area 1 subtracted by area 2. So let's do this in a bigger scale here. All right, area 1 is equal to 58 times 40 subtracted by, all right, so area of a circle is pi r squared, so pi, and the radius is half of that diameter, so this time it's 11 squared. All right, equals. Okay, this time I'm going to use the pi button, which I would always recommend doing as opposed to typing in 3.14. It just gives you a more accurate number. So I'm going to do 58 times 40, and I get 2320 subtracted by, and I'm going to go pi times 11 squared, and I get 380.1. So my final answer, my area total, is 1,939.9 centimeters squared. So just to clarify, that was area 1 that's there, and this is area 2 right there. Okay. All right, let's the last little part here is talking about volume. We're almost done. So we're looking at this, a hopper. All right, so we have the grain bin hopper has the shape of a triangle prism. So determine the height of the triangle. Well, that's this triangle right here, right? And we need to know the height. Well, to find the height, we have to look at this. So each of these is 3, right? That's 3, that's 3, and that's 3. So that means that we're going to do a right angle. There's a reason why they gave us this little right angle triangle thing here. And the reason is that we can use Pythagorean theorem, right? So if we look at that triangle, I'm going to redraw it off to the side here. And so there's 3, 3. That means that the top parts are 1.5. Right? Because it's split evenly. So that means our triangle that we're actually looking at, that we actually care about, is this. 1.5, 3, and then we have height right there. So height squared is equal to 3 squared minus 1.5 squared equals 9 minus 2.25. So height squared then is equal to 6.75. And then height is equal to the square root of that. So the height is 2.6. All right, so it was kind of a trickier question because it's an equilateral triangle and we're not given the height, so we define it. The question that's the bonus question at the end on the quiz that I'm giving you is exactly like this. So if you're lost, come back to this part of the lesson and you can go through the steps here. Okay, so now we're going to determine the volume of the prism. So the volume of the prism is always the area of the base multiplied by the height or the length, whatever one you want to say. So in this case here, our area of our base, we know that the height is 2.6 times the base, which was 3, and divided by 2, so that's the area of a triangle, right? Times the height of the whole triangle, the whole length of it, which was, oh, kind of ignored something there. Oh well, that's all right. Times 12. Okay, so our volume is 2.6 times 3 divided by 2, and then that number multiplied by 12. So I'm going to get my calculator out, give it a go. So 3.9 times 12, 46.8. And my units are in meters, so I know meters cubed. Because it's 3 dimensions. So, yeah. Now, I made a mistake on this one, so I just scratched out. And I assumed the other one was 3. Anyway, in any case. Last part. If the farmer's grain truck holds 18 meters cubed of grain, how many trips will we have to make to empty the hopper? Well, that's pretty easy. To empty the hopper, we're just going to take the 46.8 and we're going to divide by 18. And basically get 3, I'm assuming, or 2.6. There. So the truck would need to make 3 trips. Okay, what is the optimal shape when finding maximum area and minimum perimeter? All right, just like your teacher, it's a square. That's an old reference for you 60s folks. Okay, so Farmer Brown wants to build a fence for his pet hippo named Hypotenuse. He wants to build the optimal pen for Hypotenuse using a total of 756 meters of fence. Determine the maximum area possible. Right? So the maximum area is going to be, if it's a perfect square, it's going to be side times side. Or area is equal to s squared, right? So the perimeter of a perfect square is 4 times the sides. So in this case here, if we're given 756 as our perimeter, and we just need to solve for s. So to get s by all by its lonesome, we're going to divide both sides by 4. Those two cancel out. S equals 189. All right, so our area would be equal to 189 squared. Which you could figure out on the calculator. I'll leave it that way. All right, what about the minimum amount of fencing that would be required to enclose a garden that has an area of 529 meters squared? All right, minimum area of fencing. So again, it has to be a square. So if the area is equal to, right, S squared, and we're given the area, we just substitute it in for where the letter A is. 529 is equal to S squared. And so to find, we just want S, so we take the square root of 529. So S is equal to 23. And it's in meters, so I'm going to go meters, like that. There you go. Okay, that's it. That covers every single thing that we learned in this unit. So here's what we're going to do. I'm about to post the quiz. There's 9 questions, 8 of which you have to do. The 9th one is just kind of a bonus question. And it would probably take you the same length it would do on this. Do it on paper. Be careful of the units. So there's questions that you have to answer in the exact answer. And I don't just want the number, I want the units as well. So type in, if your answer is in 47 meters, to 47, and then put a space and put M. Okay? Yeah, that's pretty much it. So thus concludes today's lesson. And you have until next week. So I'm going to say Monday to complete this. All right?